All right, welcome to the first of hopefully many live stream events. I'm super stoked you guys are all here. Feel free to hop in at any time, ask questions in the chat. I'm going to be going through a bunch of interesting stuff today. And questions are welcome. Thanks for joining. So my name is Patrick. I am the creator of Objective-C. I also work for Digita Security, where we are creating enterprise tools for macOS, security-related tools. So before I dive in, I just want to thank the friends of Objective-C, briefly mention them: Digita Security, Sophos, Malwarebytes, SmugMug, the Guardian Mobile Firewall, and also the Secure Mac. So much mahalos to all of them. So today we are going to start by talking about kind of an interesting bug. It's not really a security vulnerability per se. It's more a privacy related issue. I blogged about this the other day. So what we're going to do is we're going to kind of talk through the blog, and then we're going to, once we've described the vulnerability or the issue, we're going to discuss kind of the implications of that, and then write some proof of concept code to kind of illustrate this. So you can read along. The link I will post in the chat window, or you can just follow online. So the title of the blog is Mojave's Sandbox is Leaky. And we're going to talk about sidestepping an Apple protection mechanism. And as we'll see, sidestepping this has some security implications and also illustrates how Apple sometimes approaches security. So let's dive in. So first, let's talk about background. And we're going to first talk a little bit about sandboxes. And what a sandbox is, it's basically a component of the operating system, a security mechanism that allows code, for example, to run in an environment where it is isolated from the rest of the operating system. If you're familiar with apps on your iPhone, which you probably are, these all run in a sandbox. On macOS, apps from the Mac App Store also run in the sandbox. And again, this is a really good idea because you might not, for example, trust the application fully that you're running. For example, you might not want Instagram to have access to your microphone or to your contacts. So by default, applications that are in a sandbox are prevented from doing things like accessing your contacts or accessing your photos, turning on your mic without explicit permission. So again, I'm sure you're familiar with pop-ups, for example. When you download Google Maps, it says, hey, Google Maps wants to access your location. And this is the sandbox. If you click no, the application's kind of useless, but it doesn't access your location. So on macOS, there is a sandbox. It's not maybe as strong as on iOS, but there's a lot of similarities. So again, from a security point of view and a privacy point of view, sandboxes are a great idea. Now, of course, any sandbox is going to be limited by the way it's implemented. That is to say, if it's implemented poorly, or if there's flaws, applications might be able to either escape the sandbox or circumvent certain points of it. Escaping the sandbox is something that malware will try to do. For example, if a malicious application got into the Mac App Store and was downloaded, really can't do a lot. For example, it can't really persist, it can't install a keylogger, it can't start really doing a lot of malicious activities, which is, again, good thing from a security point of view. So what such malicious code will try to do is try to escape the sandbox. And that's kind of like breaking out of prison. And so what it'll try to do is look at implementation flaws in the sandbox, maybe exploit the kernel vulnerability. And the end result, or the end goal, is to break out of the restrictive sandbox. What we're going to be doing in this blog and the code we're going to write is not escaping the sandbox, but it's going to be getting access to information and data that we should not be able to do. So this is kind of not a full sandbox escape. It's simply kind of sidestepping some specific constraints to gain access to sensitive material that, in theory, the sandbox should block. So say hi to GamerBot. GamerBot was the genius, the instigator for me to live stream. So I'm super stoked that he pushed me in this direction and that he is here watching the inaugural stream. So welcome, GamerBot. Mahalo for your many brilliant ideas. Okay, so let's dive into some specifics. So as we mentioned, we're going to basically discuss a flaw in the sandbox. And what this flaw is, it's going to allow us to access material content that in theory we should not be able to do that. So we're basically going to break the sandbox and show that in its current implementation, even on a fully patched version of Mojave, that Apple's sandbox is leaky. So before we dive into the flaw, we need to talk about something called distributed notifications. And this is discussed in the blog, but I'll briefly cover it as well. Basically, it says that these distributed notifications are a way for either applications or components of the operating system to broadcast messages across task boundaries. There's some documentation about that, so let's pop open this really quick. And in the documentation, we can see that the distributed notifications are handled by the distributed notification center. So in macOS, there's kind of this center. You can think of it as kind of like an operator, maybe at like a switchboard, for example. And what it does is anytime an application or a component of the operating system wants to broadcast some global notification, it gets routed to this distributed notification center. And then this distributed notification center, and this is important, will deliver it to any registered listener. So what you can do is you can say, hey, I want to listen to distributed notifications. And then you can basically kind of tap into this stream of events and observe some kind of interesting things going on. And we'll do this in code in a minute. Now, at this point, there's nothing wrong. There's no privacy issues here. There's no real security issues. These distributed notifications are, by design. However, as we'll see, there are some interesting notifications that an application in the sandbox should not be able to ask for or listen. Because again, the idea is an application in a sandbox is completely isolated. For example, it should not be able to see what files you're downloading, what processes you're starting, because again, that could have some privacy implications. So we talked about kind of some information about the distributed notification center. And we said that these notifications are kind of bouncing around your operating system. But in order for you as an application or perhaps a piece of malware to gain access to this, you have to register a notification. And you can do this via the CF Notification Center Add Observer API. This is a legitimate function of the information of the operating system. And if we invoke this, what we can do, this is the Apple documentation, we can see the parameters it takes are the notification center, which to add the observer, which is going to be your object, the callback, and this is important, this is the function that gets invoked when an object posts a notification by name. The other parameter that's of interest to us is the name parameter. And what you can do is you can specify that you're interested in only one specific notification or in all of them. If you're interested in all notifications, you simply pass in null. So here's some code that does this. We can basically see that we're going to register a global distributed notification listener. And again, this is going to tell the operating system, hey, anytime anybody broadcasts a distributed notification, please tell us about it, specifically invoke our callback. So if you're familiar with C code, execution starts in main. And first thing we have to do is we have to register for the distributed notifications. So we do that, as I mentioned, by invoking the CF notification center and observer. This is the API that we invoke. And we see that we tell Apple we're interested in the default notification center. So this basically says, hey, the main one. We don't need to pass in a value for the second parameter, which is the observer. However, we do need to specify a callback. And a callback, again, is a function that will be invoked when the operating system has a global notification. Let me just post this blog again in the channel if you're just arriving. So our callback, you can see, corresponds to this code. It's a static function. And again, will be invoked anytime somebody generates a notification. The next parameter, again, is the name parameter. Since we want to gain access to all distributed notifications, we basically pass in nil. Nil means null. Nil means blank. Again, in Apple's documentation, we can see it says pass null if you want the callback to be invoked for any notification posted by any object. So once we invoke this method, we have now registered with the default notification center, and we have said, hey, anytime there is a distributed notification, invoke this callback. We then invoke the main run loop. This basically just keeps our code running. Otherwise, it would obviously exit. And now we just sit in a loop. We'll execute this code in a little bit to show what kind of notifications are going on. So here's an example of running this on my system. We'll do this live in a few seconds or a few minutes. We can see I compiled my code in a program called sniff sniff and execute it. Once we have registered for global notifications, we can see that they start coming in. For example, when I lock my screen, we can see that there's something called the com.apple screen locked notification. We can see that then the screensaver turns on, and we can determine that because Apple or some system component broadcasts a global notification called com.apple.screensaver.didLaunch. We can also see a very interesting one at the bottom called com.apple.download_finished. And interestingly enough, we can see that one of the parameters that's delivered to us is the name of the file. So if we go back a second and look at our callback, again, this will be invoked anytime a global distributed notification is generated. We can see that this callback has a few parameters. Again, this method is automatically invoked by the operating system when we register via the CF notification center and observer. So the three parameters that are of interest to us are the event, which is going to be a string, a name. There's going to then be this user info, which is a dictionary, and then an object, which is just going to be some type of object. We don't know. What's important to note that these two parameters, the user info and the object, are going to be specific to the notification. So I could write an application that broadcasts a notification, and I can put anything or nothing in these two parameters. So for example, we can see that when the screen is locked, Apple or whoever is broadcasting this screen is locked, probably some component of macOS. We see that for user information, they put null. They don't put any information. However, for the object, they put 501. 501 corresponds to the primary user UID. So this is likely who locked the screen or what user was active when the screen was locked. Another example, we can see the screensaver did launch. We can see that both of the objects are null. So Apple says, okay, we're going to broadcast this screensaver did launch notification, but we're not going to give you any other information because we don't have to. So again, I just print out both of these objects because I don't know what is going to be in them because again, it's dependent based on the notification. However, we always do get this name, and this name is important. So as I mentioned, for the com.apple download file finished notification, user information is null. Apple basically has not provided us any information for this, but the object is the path of the file that was downloaded. So you can see that this is useful information. And we describe what I just said here in the blog. We can basically say The parameters are dependent on the notification. For example, for the file download, the object parameter contains the name of the file that was downloaded. So again, there's no special permissions outside the sandbox to listen for these. Apple basically saw no issue. They say, hey, if you're already running outside the sandbox, you could also, for example, just be monitoring the user's download directory so you could see what files are being downloaded anyway. And I agree with them here. There's no real privacy or security issue if you are code running outside the sandbox. So now let's dive into talking about distributed notifications in the sandbox. And here's a nice slide, kind of a pictorial overview. I gave a discussion of this vulnerability at a very high level at the Objective by the C conference. We have a nice banner over here. It's Objective-C's Mac Security Conference. If you haven't heard about it, check out objectivebythec.com. And actually, let's post a link to that in the chat room. The next one will be in Europe in end of spring, early summer. A lot of awesome Mac security talks. And if you are a patron, a supporter of Objective-C, even for $1, the conference is free to attend. Okay, so pictorially, this is a great diagram because it basically shows what a malicious lister might do and what happens if you try to do this in the sandbox. So I mentioned to listen for all notifications, you pass in nil for the name. Again, if we scroll back, we can basically see in the API to register, Apple documentation says if this parameter is null, callback will basically be delivered to you for any object. So in the sandbox, we might want to access all these notifications because, again, this is very interesting information. You can imagine an app from the App Store might be interested in what files you're downloading. And in the sandbox, you can't, for example, access or monitor what the user is downloading. Because again, the sandbox is this completely isolated, basically prison that Apple has designed so that you don't really have to fully trust an application, but you can still run it safely. And again, from a security point of view, this is a great idea. So the first thing I try to do is I try to register for all notifications. And if you execute this code, and we'll do this, and we'll be able to see this happen live, you can see that the operating system detects this and actually throws an error, a notification. It basically says, attempt to register for all distributed notifications thwarted by the sandbox. And then it gives us a nice backtrace. Here we can see sniff, sniff. This is my code. You can see I'm trying to register for all notifications because I might be a piece of malware or a shady app running in the sandbox that's trying to listen for this information. And you can see, again, Apple has basically said, GTFO, no, you cannot do this. You know, the sandbox is designed to prevent this kind of leakage. Go away. Stop. Full stop. So this is all good. This basically shows that Apple has realized the privacy implications of an application running in the sandbox being able to access all distributed notifications. For example, tracking what the user is downloading. Again, this is not something an application should be allowed to do in the sandbox without your explicit permission. So everything looks good, right? Apple blocks this, you know, in Cupertino, they're stoked, they're happy. Unfortunately, turns out that there's a very simple way to bypass that. And this is interesting because I have this quote in here that's a little, I'm not going to say harsh, but maybe a little provocative. And it basically says that security at Cupertino is often approached in a rather lackadaisical manner. In other words, it's often not always thought through. And for example, their attempts to block the receiving of distributed notifications globally from the sandbox we'll see is a perfect example. So Apple has said, hey, we don't think you should be able to register for distributed notifications globally, which I agree with. And they put in this code to block you from doing it. And then they say, okay, cool, we've dealt with this. The problem is there's a way to get around that. And we'll discuss that right now. So again, this is a 0-day vulnerability. It doesn't have any security implications in, you know, my personal opinion, but it does have privacy concerns or privacy issues, and it sidesteps one of Apple's privacy mechanisms. So I think it's a real issue that Apple will likely fix. So again, we mentioned Apple prevents an application from registering to receive all notifications. But, and this is important, there is nothing preventing a sandboxed application from registering to receive any notification by name. This means in the sandbox, we can still register for the com.apple download file finished notification and any notification. So as I mentioned in the blog, we can basically bypass Apple's sandboxing protection by simply registering for any and all notification by name. So again, just to summarize for the people who are just joining us, if you pass nil, that basically tells the operating system you're interested in all notifications. In the sandbox, this is blocked, but what you are still allowed to do, and this is an oversight on Apple's part, is you can register for any notification by name. So this means we can just find out the names of all the interesting notifications and register for each of them by name, which cumulatively allows us there to register for any and all notifications. So we're back to basically square one, which is where we want to be, and that is being able to, from within the sandbox, sniff and capture all notifications. And for Cupertino, this is less than ideal. But again, this kind of shows how Apple sometimes approaches security. So again, here's a slide that provides a little more illustration of that. Again, it articulates maybe more clearly just what I said. Again, in the sandbox, we can't register for all notifications, but we can register for individual ones. So here's some interesting ones that we can register for in the sandbox that may not allow, or rather that Apple would rather us not allow to sniff. So for example, application registered, file downloaded, unmounted, et cetera, et cetera. So let's look at an example, kind of put interest in here. And oh, welcome, Stuart. Oot. So say a malicious application wants to monitor all the files you download. This is not something that an app running in the sandbox should be allowed to do, because you can imagine you might be downloading some files that you don't want applications knowing about. So the first thing we do is we turn on the sandbox, and you can do that very easily in Xcode. You basically check the sandbox config, turn it to on. We then write some code. This should look very familiar to the code we wrote earlier, save for the fact that right here, instead of passing nil, we pass a name. And this name is the notification that we want to sniff in the sandbox. So in this case, you can see it's the com.apple.download file finished notification. So we execute this. And again, remember, we're now running in the sandbox, in this prison, this jail, where in theory we should not be able to see what is going on outside the sandbox. But when we do that, we can see that if we get this on a machine, we can see that the user has downloaded a file, for example, the ptapes.move. So, this is probably, obviously, very clearly a privacy issue. A sandbox application should not be able to monitor what the user is downloading. Now, one thing to note is that the sandbox prevents us from actually seeing the contents of that file. We can't actually go and open that file and read it. But via these distributed notifications, we get the name of the file, which can be very implicative. For example, if you're downloading adult content, certain sensitive information, the file name can still be very revealing. So again, that's important to note that there are some limitations to this technique because of other aspects of the sandbox that Apple has implemented correctly. So you might be wondering, okay, great. Patrick, you have shown that we can basically bypass Apple's privacy mechanisms in the sandbox by registering for distributed notifications by name. Again, we can't do that globally. We have to do it by name. So the question then is, how do we find what distributed notifications we can register for? In other words, what ones are being broadcast? Like, how did I find out about the com.apple.download finished? So that's actually a great question. And it turns out there's not like this cumulative database that has all these names. So we basically have to figure them out another way. So the easiest way is to run a global listener outside the sandbox, which we are allowed to do, and then basically just watch what distributed notifications are being broadcast or bounced around the system. Again, we could do that using the code I showed earlier, but what I actually did was I used Digita's Monitor Kit. And Monitor Kit is a really cool project I've been working on, and the other guys at Digita. It's going to be open source shortly. And as its name implies, it basically allows you to monitor all sorts of interesting things. And one of the things you can register and listen for are distributed notifications. It's a framework that has Objective-C and Swift bindings. I'm trying to learn Swift, modernize. So in this case, I wrote some Swift code that interfaces with the Monitor Kit framework. And basically, I tell the framework that I'm interested in all distributed notifications. Again, I'm running this outside the sandbox to get the name of the notifications so that I can then go back inside the sandbox and register for all interesting notifications by name. So you can see here's the code. It's just a few lines of Swift. We basically import the Monitor Kit framework. In our application main, we create a monitor. And then we basically start the monitor. And this is the name of the monitor for Monitor Kit. So we tell Monitor Kit, hey, we want to basically, we want access to your distributed notification monitor. And then we start it and we pass in a block. A block is kind of like a callback function, but it's basically inlined. And what we do is we print out the name of the distributed notification, which is the most interesting thing to us, and then also the event info and event object, which can be null. So once we run this, I then just use my computer for a few days to see what notifications are kind of bouncing around. And here are some interesting ones that may have some privacy implications that Sandbox application probably should not be able to have access to. So the first one is the com.apple.launchservices.application registered notification. So if we register for this one in a sandbox, we can see anytime a new application is registered. Again, you might not think that this is a big deal, but again, from within the sandbox, this is not something an application should do. A sandbox application has no business seeing what other applications you are installing. Another example is I'm just going to highlight this, it's too long to read, but basically there's a variety of Xcode notifications that are broadcasts. So again, in the sandbox, we can register for these notifications by name, and we can basically see now what files the user is editing in Xcode. Again, this isn't the end of the world, but a sandbox application should have no insight into what source code files you're working on. Applications in use is another cool one. Basically, the com.apple.sharedFileList.change notification is broadcast when applications are launched or when they're editing, for example, certain files. So in the event object, we can see that the bundle ID, for example, com.apple.iChat, com.apple.textedit, is broadcast to us in the sandbox when these applications are in use. So again, we can now determine what applications the user is using, which again breaks a fundamental design component of the sandbox, which is this privacy and this isolation. This next one's kind of neat. We get the loaded text notification. This will be broadcast when a new kernel extension is loaded. Again, this is not something that an application in the sandbox should have any insight into. This is probably the worst one. This is the one we talked about, the com.apple.download file finished notification. This allows us to monitor what files the user is downloading. And this can be, anything, applications, if they're downloading adult content, we get the name of the file. So again, you can imagine some app from the App Store can now basically sniff and monitor all your downloads, and who knows what it will do with that information. So again, this is a clear privacy violation. Other notifications that are broadcasts by name that, again, we can register for in the sandbox is the com.apple.multitouch support HID device added. This will be broadcast along with the type of HID device, which is a human input device. And again, this will be things like if you attach a mouse or a board. So now applications in the sandbox can get some information about hardware devices. The Bluetooth stack also broadcasts a large number of notifications. For example, we can see the com.apple.bluetooth.status notification is broadcasts. And again, in the sandbox, we can register and gain access, capture this notification. And it has a list of all the Bluetooth devices that are attached to your system. So you can see I have an Apple trackpad, a Logitech keyboard, and some Bose headphones. And finally, you can register for the com.apple unmount assistant process start notification, and this will be invoked anytime a USB device is removed. So this gives us access to the name of whatever USB device that is getting plugged in. Now again, from the sandbox, we should not be able to gain access to this if the sandbox was designed well. And again, the name of the USB might be very interesting. For example, here there's a USB called TSSCI, which stands for Top Secret Secure Compartmented Information. You know, if you see this, this basically might indicate that the user is plugging in a top secret USB. So immediately you know this is a target of interest. And at this point, you might download and execute a full sandbox escape because you're like, this is a target that's very interesting to you. Okay, so let's wrap this up. Basically, we showed that Apple Sandbox, by design, blocks the global registration of the global registration of all notifications. And what that means is if we pass in nil for the name, basically says, hey, we want access to all notifications, the operating system basically tells us to take a hike. It basically says, no, you can't do that. That would violate the sandbox. However, what we can do is register by name, each one specifically, which cumulatively allows us to listen and receive and capture any notification. So we achieve the same thing, sidestepping Apple's privacy protections of the sandbox. So again, this isn't necessarily the worst security vulnerability per se, but I think it's still an interesting bug because it's very illustrative to the way kind of Apple approaches security in some cases. And that says, you know, hey, we know that we should block these distributed notifications. They kind of slap a, you know, 1 or 2 lines of code to block this, but they don't really think this through. So unfortunately, it's up to people like myself or other security researchers to reverse engineer the operating system and dig around for these bugs to see how Apple has implemented them. And is often the case, there are flaws in this technique. So good news is I reported this bug to Apple, and I'm sure that they eventually will fix this because again, as we can see, they try to block distributed notifications. So again, to me, this confirms that they realize these shouldn't be captured in the sandbox. So this bypass is likely of interest to them. So now let's look at some code. Let's actually write a proof of concept that will allow us to perform this attack. So let's close some of these windows. I'm going to open an Xcode project, file, new project. Let me drag this over here so we can all see this. I'm going to create a Cocoa application, and we'll call it next. Let's call it sniff Twitch. Cool. Create. Come on, Xcode. Okay, so it's just a standard application, nothing too exciting here. Hop in application app-delegate.m. This is where code execution will begin in the application's main. Apple has basically created this boilerplate code that shows us the code and basically has said, insert any code here. Let me just close all these to gain any, insert code here to initialize your application. So what we're going to do is we're going to put in code here. This is first going to run outside the sandbox. So we're going to register for all notifications, and we're going to then see that anytime a application or the operating system broadcasts a notification, we will basically get that notification. Then what we'll do is we'll put the app in the sandbox. We'll show that that fails because of Apple's protection, and then we'll show how we can sidestep their protection by registering for each notification by name. So I'm going to copy and paste the code because I actually suck at typing. So let's go back to the blog. And okay. We need two things. We need our callback code, and then we need the registered notification. Okay, so again, code execution is going to start here. Code execution here. So let's register for all notifications. And again, we do that via the CF notification center add observer API. We tell the system we want to register with the default notification. We pass in nil, and again, nil is none, blank, nothing. And again, Apple has told us if we register for that, this will give us all notifications outside the sandbox. So we can jump to the definition and we can see that the names of the parameters, the center, the observer, callback, and the name. Again, we set name to nil to register for everything. So if we compile this code, it's going to take a second to build. Again, this code is not going to be run in the sandbox initially, but what it will do is it will capture all notifications. Okay, so if we run this, hopefully this works. Demo gods. Should have given them an offering. Come on. Okay, there we go. Oh, cool. This is actually good. So this says attempt to register for all distributed notifications forwarded by the sandbox. And this is by default. When you create an application, Apple puts it in the sandbox. So this illustrates the second thing I wanted to do, which is actually when we try to register for all notifications, when we're in the sandbox, Apple will block that because again, it's not something they want us to do. So if we go to capabilities, we can see that the sandbox is turned on. So for illustrative examples, we're going to turn it off for a second. We're going to run this application again. And let me at least put a little log message in here to show hello Twitch followers. And this has to be an Objective-C string. Okay, so we're going to run this again. Again, I've turned off sandboxing, so this is running outside the sandbox. We can see, okay, it says hello, we've registered for notifications, and now we need to do something that triggers a notification. So let me go back to Chrome and download a file. So Objective-C, let's download knock knock. This could be any file, even in incognito mode. So that will not save you. So we downloaded the file, knock knock 2.zip. If we come back to here, we can see that we received a notification for knock knock. We can see that the notification is called com.apple.download file finished. We can see that the user information was null. Whoever broadcast this notification, which in this case is the operating system, didn't provide us any information, but we can see that the object had the full path to that. So again, this allows us to sniff what the user is downloading. There's other notifications that we could illustrate. If I locked my screen, there would be one. If I plugged in a USB and unplugged that, if I loaded a kernel extension, we can see that there's another one that was com.backup registration. Again, if I would use my system for the next few minutes, we would start seeing these random distributed notifications kind of come in because we've registered outside the sandbox to gain access to all of them. Now, what we're going to do is we're going to illustrate the vulnerability. As I mentioned, we have to register by name. So what we're going to do is we're going to go back and we're going to turn on the sandbox again. If we run this, as we just saw the first time I ran this, we're going to see that this throws a big mean error. And again, Apple basically is saying, get the heck out of here. Basically saying, you attempted to register for all distributive notifications. You are in the sandbox. You are not allowed to do that. Okay, so agreed. What we can do is we can register by name. So we make a new variable. So we can enter a string and call it name, and let's set it to whatever notification we're interested in. In this case, the download one. We can then come to, oh, it'd help if I could spell, back to our notification register function. And for the name parameter, we can put in the name. If we now build this, I think it's going to complain because this API is a core foundation API, which doesn't like NS strings. So I think we can typecast this. CF string ref, maybe something like that. This might crash and burn, but it might work also. Okay, so we'll see. This is how I code. I'm like, yeah, maybe it'll work. If it doesn't, we'll come back and fix it. Okay, so now again, we're running in the sandbox. So in theory, we should not be able to monitor users' downloads because that's obviously a very private thing that the user is downloading. So let's open an incognito window and let us go back to Objective-C and download something else. So let's download Do Not Disturb. All these pop-ups, geez. Oh man, 9 megs. Should have picked a smaller one. That's because it has a Swift framework and Swift files are huge. So let's go see if we can download something smaller. Block. Okay, so again, we're in incognito mode. We're running in the sandbox. This works. Okay, cool. So again, this illustrates the vulnerability quite well. Again, we're running in the sandbox. We have registered for notification. We can't register for all, but we said, okay, let's register for the download file, finish one. And even though the user is downloading files in a separate application outside the sandbox in incognito mode, our malicious sandbox application can detect and sniff these. So this kind of wraps up this section of the live stream. What we did was we basically talked a little bit about distributed notifications. Again, for those just joining now, these are broadcast by the operating system or applications when interesting things happen. For example, when you download a file, when a kernel extension is loaded, all sorts of events. Apple, by design, tries to prevent sandbox applications from gaining access to these notifications because they can contain sensitive things. For example, the names of the files that the users are downloading, which might be very private or specific to the user. However, we showed that if we register for notifications by name, we can register for any and all notifications, which basically gives us the ability to sniff global notifications, these distributed notifications, even within the Mac sandbox. So again, this bug was reported to Apple. Again, it's not a huge security issue, but it does illustrate that their sandbox, even in the latest version of Mojave, is leaky. And more important to me, it showed that even though they were aware of this issue, or realized rather that distributed notifications should not be accessible in the sandbox, the way they tried to protect against them was very kind of half-assed. And we see that time and time and again. So we're going to now hop to another part of the live stream. If you guys have any questions about this, feel free to ask away in the chat. Or again, the blog, which I will post again, has kind of more information about all of that. Awesome. And while you guys are here, make sure you subscribe because I'm planning to stream a bunch.